Hi there, welcome back to my channel, and in this video I want to take you through relative minimums and maximums. In our previous lessons we've gone through tangent planes, normal line, then also we found the linear approximation of multivariable function. If this is the first time being on this channel, kindly subscribe to support and please watch this video to the end. I have a problem here to explain this concept to you. Find and classify all the critical points for f of x y, which is equal to 3x squared y plus y cubed minus 3x squared minus 0y squared plus 2. So it said we should classify, right? So classification means that after finding the critical points, we need to classify them whether they are minimum, they are maximum, or saddle. Okay. So when we say relative minimums and maximum, all that you are trying to say is we want to find the peaks in what? In our graph. In calculus 1, you realize that if you have your plane and you have a curve like this way, you realize that at these points, at the peaks, right, it's either minimum, which is this form, or maximum, which is up, right, or maximum. Okay, so grouping your critical points. So this point at s equals this, or the value that gives the peaks, are what we call the critical points. And at this point, the function switches from what, maybe a decreasing towards an increasing nature. Okay, so that's what we call critical points. So critical points are special points within the domain of the function where the function switches a direction. Okay, so the function started here increasing. So upon reaching this critical point, it will then start out decreasing. So at the critical point, it relaxes and changes direction. So critical points are special points, and one key thing about critical points is that the derivative at the critical point is zero, because at the critical point there is no movement. That is why it changes, then it continues again. So it will first rest and continue each journey. So with this simple scenario, let's see how we find a critical point. So to find a critical point, you simply have to find out from calculus 1 your derivative with respect to what. So initially we say that f of what, x prime, should be 0, right? But now this is a multivariable function. So for multivariable function, you need to find the partial derivatives with respect to each of the independent variables. Okay, and they should be equal to 0. Okay, they should be equal to 0. So with this, I'll have my partial derivatives. So I have my fx. Okay, my fx simply becomes what, whatever is y becomes a constant. Okay, so here I'll get 6xy. This is 0. This I'll get negative 6x, right? Then the rest are 0. So this is my fx, and they are saying that our fx should be what, equal to 0. So we are going to have 6xy minus 6x equal to 0, right? So I can factorize 6x out, right? So I'll have 6x out, y minus 1 is equal to 0. So meaning s equals 0, y is equal to 1. So I'll put these two values down. Now what about my fy? My fy is equal to whatever I see x becomes a constant. So here I'm going to get 3x squared, okay? 3x squared, because y, when I differentiate, so I'll get 1. When I differentiate y, I'll get 3y squared here. So plus 3y squared, okay? Then this becomes 0, and I'll have minus 6y. 2 becomes 0. So right now I have this, and this should also be equal to what? 0, right? 3x squared plus 3y squared minus 6y should also be equal to 0. So a critical point, this is just a single coordinate. Okay, we need two coordinates x and y to form a critical point. So now once we have got this, we know that from our first critical point we have the x to be what, 0, we have y to be what, 1, right? So meaning these are two key points, or two coordinates we found for us to get the corresponding terms to get a complete point. Okay, so in this I can say that when s is equal to 0, my fy will become what, I'll put x equals 0 here. So I'll get 3 multiplying 0 all squared plus 3y squared minus 6y equal to 0. So obviously this is 0, so I'll have 3y squared minus 6y is equal to 0. So for here, I'll factorize or 3y out, 3y out, right? So 3y minus what 2, right, equals 0. So from here, I'll get y equals 0, then y is equal to what 2. Is that not it? Y equals 0 and y equals 2. So then, if s is equal to 0 and I'm getting two y values, I'll say that the first two critical points is equal to the x being 0. You see, when s is equal to 0, that's what I use, right? But initially, it has 0 and what 1. So when s equals 0, so I have x0, comma what y0. That is one critical point. I can also have x0 and y hot 2. So these are two critical points I have found here. Two critical points I have found here. Okay, two critical points I found here. Now the next thing to do here is to find the rest of the critical point, because here I found it when x equals 0. Now I can find it when y equals 1. So when y is equal to 1, what do we get? So I'll simply put y inside. Okay, so putting y here, what am I getting? Y equals 1. I'll get 3s squared, right, plus 3 multiplying 1 squared minus 6 multiplying 1 equals 0. Okay, so this is all 3s squared. This is what 3 minus 6, negative 3, should give me 0. Okay, should give me 0. So let's see. So right now, when y is 1, what are the critical points I'm getting here? So let me see here. The y squared. Yeah. So when y is 1, for here I'm getting x. So here is 3s squared. So I'll get 3s squared equals 3, right? So I'll cancel my 3 out and I have s squared is equal to what? 1. Therefore, s is equal to plus or minus what? 1. Therefore, the next critical points, I've got critical points is what? When y is 1, so you just write 1. Then the x will be what? 1. So 1, 1. Then when y is 1, x is what? Negative 1. So negative 1, 1. So therefore, this particular function here has given us 4 critical points. 1, 2, 3, 4. So the question said we should find and classify. So now we are left with what? The classification. So how do I classify my critical points? How do I classify my critical points? So in the classification of critical points, we find a particular function which we call D. So D is a determiner whether a critical point to be maximum, minimum, or what, a saddle. So D is found by f of xx, okay, multiply by f of yy, okay, minus f of xy all squared. So we simply find the second derivative of what? X with respect to x, then second derivative of y with respect to y itself. So after we have got fx, we find another fx again of the same thing, and likewise fy, we find fyy. Okay, and after we find fxy all squared. This will give us a determinant expression. Then, because we want to classify a critical point, you find the d at the particular critical point. So the d at a particular critical point is a d of what? AB, right? Assuming a and b are the critical points, is equal to f xx of what? AB multiplying fyy of AB minus f of fxy of AB all squared. That's all. We have some few conditions here. The first condition is that after finding your d function at a particular critical point and d is greater than 0, whilst the fxx ab is also greater than 0, then we say that our function is a relative minimum. Okay, so see the condition here. D should be greater than 0. Yes, when d is greater than 0 and the second derivative with respect to what? Xx is what? Also greater than 0. Then therefore it's relative minimum. Relative minimum. Then also number 2, when d is also greater than 0, right? Then fxx of AB is less than 0. Then we have relative maximum. Relative maximum, okay? But the third condition is when d is less than 0, right? When d is less than 0, then the point AB is said to be a saddle point. A saddle point. So saddle points are points which are neither minimum nor maximum, and at that point there is a constant, change. Okay, a constant change. A constant change. Now, if you find d and d happens to be equal to 0, then you say it's indeterminate. Okay, you can't determine it. When d is 0, it can either be minimum, maximum, or even saddle point. So you have to use other techniques to classify. So now these conditions are what you are going to use to classify the critical points you have now. So let's see how you apply that. So let's find d, the function d. So to find the function d, I'll simply have my d. So I'll find fxx, right? To find fx, I know my fx. Okay, this is fx. My fx is 6xy minus what? 6x. So fxx, I will differentiate this same function with respect to x, meaning my y becomes a constant, right? So differentiating this with respect to x, I'm going to get 6y. Differentiating this two with respect to x, I'll get minus 6. Now what about my fyy? I'll differentiate this function with respect to y. Okay, so differentiating it with respect to y, I'm getting, here will be 0. Okay, this place will be 0. So I'll also get 6y minus 6. Then the next thing to find is what your fxy. So I'll differentiate either this with respect to what, y, or this with respect to x. Okay, so differentiating this with respect to y, what am I getting? My fxy happens to be what? This will be 0, and this will be what? Differentiating this with respect to y, I'll get this to be 6x. 6x. When I differentiate this also with respect to x, this will be 0, this will be 0. I'll also have 6x. So they are equal. That is why we use a Clairaut's theorem that whenever a function is continuous over a domain, then your fx and your fxy and your fyx are always equal. Okay, so it holds here. So the d, what's the d? So as I said, the d is what? You are multiplying. So realize that even our fxx and our fyy are equal. So my d is simply equal to, let me find my d somewhere here. My d is equal to, I'm multiplying fxx. So the formula is fxx times fyy, right? So I'll have 6y minus 6 multiplying 6y minus 6, which is this and this, minus what? 6x all squared. Okay, so this is my determinant function. At this point, I simply have to take all the critical points one by one. I have 4 critical points. I have 0, 0, 0, 2, 1, 1, negative 1, 1. Okay, so for me to classify them, I'll start with the 0, 0. So classification of the 0, 0. So 0, 0. What do? I have to put the various components. So when I put 0 here, I'm going to get what? My d to be equal to, here will be negative 6 times what? This one to be what? Negative 6, right? So I'll just get positive what? 36. So I'm going to, so I'll have something like negative 6 times negative 6 minus, when I put x is 0, everything will be 0, minus 0. So this is giving me what? 36. So if d is 36, meaning that d is what? Greater than what? 0. So the first condition is satisfied. Now, what are we left with? The next thing to do is what? To check your fxx. This is the fxx. Okay, we handle this fxx. It's very necessary. So we put our critical point in the fxx. When I put it in the fxx, which is 6y minus what? 6. When y is 0, I get what? Negative 6. So my fxx at the point 0, 0 is what? Equal to negative 6. And that is what? Less than what? 0. So the condition said when our d is greater than 0 and our fxx at AB is less than 0, is what? Relative maximum. So therefore, the critical point 0, 0 is relative maximum. Relative maximum. Okay, relative maximum. Then our next critical point is 0, 2. Okay, 0, 2. So quickly, our d will be what? When I put my y is 2, so my d will be equal to 6 multiplying 2 minus 6, and it's squared. Okay, all this squared minus, but it's the same thing. Minus this is what 6x squared. My x is what 0, so that place will be 0. So my d is simply equal to 6 times 2, 12 minus 6 is 6 and it's greater than 0. Okay, so once I see that my d is greater than 0, then I'll move towards my fxs test. So my fxs, when I put y in it, y is what 2. 2 says 12 minus 8. I'm also getting 6. So fxs is also equal to 6 and it's also greater than what 0. What does that mean? Meaning that my point 02, my critical point 02, right? So my critical point 02 is what? Relative minimum, right? Relative minimum. Then let me come to my critical point here. So my critical points up here were what? 1, 1, and what? Negative 1, 1. So let's try that one too. So for 1, 1, my d becomes what? My d is what? 6 times 1. 6 times 1 minus 6 all squared. Okay. Minus my 6x squared here. It's what? 1. Is that not it? So it's 1. So when I get that, I'm getting 1. So I'll have minus 6 multiplying 1 all squared. So here becomes 0. Here becomes negative 36. Okay, negative 36. So my d is equal to negative 36. Remember, when d is less than 0, the condition is a saddle point. You need not to do any test again. So we simply say that the point 1, comma 1 is what? A saddle point. A saddle point. Now let's finally check negative 1. So negative 1, 1. For negative 1, 1, my y is still 1. When y is still 1, you know that you have 6 multiplying 1 minus 6 all squared. Then minus our 6 multiplying our x, which is what? Negative 1, right? All squared. So obviously, you have this place to be 0. 6 minus 0 minus 36. So our d is still, for that reason, the point negative 1, 1 is also a shadow. Right. So now we've been able to classify all our critical points. We have 1 to be relative maximum, relative minimum, then the 2 are saddle points. Thank you for watching this video. Please don't forget to like, subscribe, and share.